Hello everyone and welcome back to another diagnostic video. Today we're going to be looking at a 2009 Nissan Murano, and the problem with this vehicle is it has an intermittent charging issue. According to the customer, the owner of the vehicle will drive and intermittently the car will stall, and then he has to boost it to start the vehicle again. There's no rhyme or reason to when it'll do it. It's very random, very intermittent. Now with this one, we decided to scan the vehicle for codes. Did not find any relevant codes to our charging issue. So from there, we went and had a look at charging data. All right, here we have some pretty basic data on the charging system. This is all that Nissan really gives you for charging system battery data. We have our battery voltage, alternator duty, battery current, and then alternator duty signal. At this point, it looks like our alternator is charging the battery properly, but this is an intermittent issue, so it's not really surprising to see that it's charging fine right now. What we can do in the meantime is we can go over to, there's an active test to test the alternator and duty cycles, so we can ramp the alternator duty cycle up and down. So I think we're going to go do that next, just to make sure that the alternator is being controlled properly and that it does respond to our commands. All right, so here we have it commanded at 20%. You can see the battery voltage drops to about 12.8. This is normal on a Nissan. They have varying levels of charging voltage for depending on the demand from the vehicle. So 20% appears to be 12.8 volts. This would be your low load cruising down the highway type charging voltage. So this is fine. This is normal here. And as we ramp it up, you can see we called for 60%, and the battery voltage comes up slightly to 13.7%. This is more moderate load on the electrical system. It starts ramping the voltage up. And as we get to 100%, this is heavy load battery charging, and you can see it's really working this alternator, charging it at 15.5 volts. So this alternator appears to be able to charge the vehicle right now, and it appears to be listening to our commands to ramp battery voltage up and down. But like I said previously, this is an intermittent issue, so we're going to have to hook some stuff up to the vehicle, our scope and monitor, battery voltage, battery current, stuff like that, and drive the vehicle around and wait for it to act up. Before we get started and hook stuff up to the vehicle, I'm just going to go over the wiring diagram really quickly here to explain how this system works. We have five wires on the connector at our alternator. We have our main alternator ground here, the circuit to charge the actual battery. This circuit here, pin 3, is our charge indicator circuit. When it detects that the voltage is low, it grounds this circuit, which turns the charge indicator on. Here on pin 4 is our sense circuit. This is how the alternator knows when system voltage drops. And on pin 5 here is our alternator command from the intelligent power distribution module. Now on pin 5 here, you can either have a 0 to 5 volt square waveform, or it can be flatlined at 5 volts. Both are kind of normal. And in our case, ours was flatlined at 5 volts, and you'll see that here shortly once we get hooked up to the vehicle, but that is totally normal. So let's go over to our scope shot, and I'll show you what we found. All right, so here we have our scope shot of the charging system. Our blue trace here is our sense circuit. It's where it monitors system voltage for any potential issues. Here we have our battery current. So we have our current clamp around the negative battery terminal. The red trace is our command from the IPDM, and the green trace here is our charge indicator control circuit. So if we just go and have a look here and see what our charging system voltage is, or our system voltage is, we're sitting at about 11.5 volts. So this vehicle is currently not charging. Now I just started the vehicle up, and it should be charging right now, but it is not. So we just have a look here and see what our current draw is at, or what our current's sitting at. We're sitting at about 26 amps. So this vehicle is running off of the battery right now. All the electrical components and the vehicle, the entire system is running off of the battery. Typically, when you fire a vehicle up, it just uses the battery for the starter, and then the alternator then switches over and takes control of the rest of the vehicle. And the alternator is actually what maintains the battery, and it also runs all the vehicle electronics and the other systems on the vehicle. So currently we are drawing about 26 amps, and that's all just to run the vehicle. Our red trace here, now I don't know if you remember in the last slide there, I said that the flat line at about 5 volts is totally normal, and here we are flatlined at about 6 volts, and that's totally fine. That's normal. That is the IPD. I'm commanding this alternator to charge, but it is not charging. Now, our green trace here should be high at 12 volts, and when there's a system issue, it grounds that circuit and turns the charge indicator light on. So currently the charge indicator light is on in the dash, and this vehicle is not charging. Now I'm just going to swap over to the next slide here. That is where the vehicle all of a sudden started charging, the charge indicator light went out, and everything returned to normal. So here you can see the system voltage jumps up to about 14.5 volts. The charge indicator light, or the charge indicator circuit becomes ungrounded, back up to around system voltage. And you can see that the current drops way down. And I'm just going to move over to the next slide here so we can see battery current a little bit better. One more. We can now see that the alternator is putting about 30 amps into this battery, which is it's kind of what we'd expect to see when you have a discharged battery. That's okay for the first little bit, but after about, I don't know, 20 minutes or so of running, that should come way up and should only be around between 5 to 10 volts or sorry, 5 to 10 amps at the most to maintain that battery. So we're going to let this vehicle run for a little bit. And then I'm going to take it for a drive just to see what it does on the road. We should see this should all stay normal. This should all stay the way it is here. These should be around battery voltage, both of these circuits. This should maintain around 5 volts. You may see a square waveform as well, but it should either stay 5 volts or it should see that square waveform. And this should come up to about 10 amps, right around here somewhere. So let's swap over to the next slide from where I was driving the vehicle, and we'll see what it looks like there. Okay, so this is our second scope shot here. This is after driving the vehicle for several minutes. You can see that our amperage has come way down. We've got about 10 amps going into this battery, which is normal for a good battery. You can see that our command is still sitting at 5 volts, and our sense circuit and our charge indicator circuit are both sitting high at system voltage. So this is normal. This is the way everything should look with a good charging system, good battery, and the vehicle running totally normal. So now I'm just going to flop over to the next page here, and you'll be able to see what it looks like kicking in and out. So you can see here the charge indicator circuit goes low. That's where the charge indicator turns on the dash. You can see our amperage comes way up. This is where the vehicle system is running off of the battery and not the alternator. And you can see that the system voltage is slowly starting to drop off as the battery depletes. And then here it kicks back in. The charge indicator circuit goes high. Charging voltage comes up, and our amperage comes way down again. Now, the whole time this is happening, you can see that our 5 volts command circuit is staying steady at 5 volts the entire time. Now, this is with me probing it at the alternator itself, not at the IPDM. The reason I went to the alternator is if it maintains 5 volts here the whole time during the issue, then that tells us that our circuit for that our command circuit is good. The integrity of the command circuit is good. There's no corrosion, no broken wire or anything like that. If I had checked it just at the IPDM, that just means that it's good coming out of the IPDM. We could still have a wiring issue or corrosive wiring or something like that, where you'd have 5 volts coming out of the IPDM, but you may only have like a volt, volt and a half, or no voltage at the alternator itself. So that is one reason I checked it right at the alternator, and you can see the entire time it's staying solid at 5 volts. So the vehicle is commanding this alternator to charge, and the alternator just can't handle it. There's something wrong with the alternator. Not sure exactly what is wrong with it, but you can see that it just quits charging intermittently, and that was kind of the issue that they had. The customer complaint was that it died on the road. No rhyme or reason to it. It just sometimes would die, and other times would drive fine. So at the end of the day for this one, it needed an alternator. That's what the shop installed, and vehicle's been running fine ever since.
If you like this video, please let us know by following us or liking us on Facebook, Instagram, Twitter, and YouTube. And if you want access to more in-depth training videos, please visit our website at www.autoaid.ca. Thanks for taking the time to watch this video.